Hello everyone, welcome to my channel. Today's topic of discussion is Vigenere Cipher. So following topics will be covered in today's video. What is Vigenere Cipher? Formula for encryption and decryption using Vigenere Cipher. Then we'll do a numerical on encryption using Vigenere Cipher. And I shall be covering the numerical on decryption using Vigenere Cipher in the next video. So let us begin with what is Vigenere Cipher. Vigenere Cipher is a type of encryption and decryption algorithm. The encryption algorithm is used at the transmitter end in order to convert the secret message, also known as plain text, into a meaningless message which is known as ciphertext. The decryption algorithm, on the other hand, is used by an authorized user at the receiver end, and the authorized user recovers the plain text from the ciphertext using the decryption algorithm. The main feature of Vigenere Cipher is that it is a polyalphabetic substitution cipher, and because it is a polyalphabetic substitution cipher, it is cryptographically stronger as compared to that of a monoalphabetic substitution cipher. In order to make the Vigenere cipher cryptographically stronger, that is, in order to make it a polyalphabetic substitution cipher, Vigenere cipher uses a key which is a word or a phrase or a sentence. The key is not a fixed number that was in case of scissor cipher, multiplicative or affine cipher seen in previous videos. Before we go to the details of Vigenere cipher, let us first see what is the formula that is used for Vigenere cipher. Any encryption algorithm takes the input as plain text. It uses a key K and generates a ciphertext C. Now let us denote PI as the ith letter of the plain text. Let us denote KI as the ith letter of the key, and let us denote CI as the ith letter of the ciphertext. Now Vigenere cipher will take the ith letter of the plain text. It will take the ith letter of the key and generate the ith letter of the ciphertext using the formula CI is equal to PI plus KI mod 26. Now this ciphertext is given to a decryption algorithm at the receiver end. So the decryption algorithm will use the input CI, it will use the input KI, which is the ith bit of the ciphertext and the ith bit of the key, and generate the ith bit of the plain text. So the decryption algorithm will recover the plain text using the formula CI minus KI mod 26. Therefore, the first formula shown here is to encrypt the plain text and generate the ciphertext using encryption algorithm, while the second formula shown here is the decryption formula which recovers the plain text from the ciphertext. Now note that we have used mod 26, that is, we are going to perform the modular addition and not the normal addition. So mod 26 basically indicates that the algorithm or the formula is going to work on finite field of 26 numbers. So we will be basically doing the computation on numbers between 0 to 25. That is, the value of PI, CI and KI will always be between 0 to 25. That is, we are working on a finite field of 26 numbers, and hence we are using mod 26 addition for encryption and mod 26 subtraction for decryption. So with this, we'll now learn how to solve a numerical using Vigenere cipher. So the given numerical is to encrypt the plain text secret message with the key wise using Vigenere cipher. We will start the encryption by first drawing a 3-column table. We'll fill up the first column with the given plain text. So the given plain text is secret message. So I'll write down all the letters in the first column. So SECRET space MESSAGE. So I've written the plain text letter in the first column. Then I will fill up the key which is given, that is wise, in the second column. So the key is given as WISE. Now the length of the key is 4 letters while the length of the plain text is larger. So I have to cover up the remaining plain text letters as well. So we repeat the key again in Vigenere cipher. So I write down the word wise again. So WI, since there's nothing to encrypt here, we leave a space and write SE. Because the key is exhausted, again we repeat the key wise here and then again repeat. So as you can see here, you have to go on repeating the key as long as you cover all the letters of the plain text. Now the formula that is used for encryption is, it is the ith letter of ciphertext is generated by taking ith letter of the plain text added with ith letter of the key, and the addition is a mod 26 addition. So the ciphertext is generated calculated by doing modular addition. That is a mathematical procedure which requires numbers, while the plain text that is given to us and the key that is given to us are in the form of characters. So the next step here is to assign numbers to each of these characters, and this can be done by using a mapping table, which we have also been using in multiplicative cipher and additive cipher, in which A is assigned a number 0, B is assigned a number 1, C is assigned a number 2, and so on and so forth till we reach Z, which is assigned a number 25. So we use this mapping table and assign the numbers to the corresponding letters. So in order to assign each of these letters to numbers, we'll use the mapping table which is shown at the right. So it can be seen from this mapping table that S is assigned a number 18, E is assigned a number 4, C is assigned number 2, R is 17, E is 4, T is 19, M is 12, E is 4, S is 18, S again is 18, A is 0, G is 6, and E is 4. Similarly, we'll also assign numbers to each of the letters of the key. So first letter is W. W is assigned to number 22, I is assigned to 8, S is assigned to 18, E is assigned to 4. So we'll repeat this number again. 22, I is 8, S is 18, again E is 4, again W, 22, 8, 18, 4, and again 22. So I have assigned the numbers to the plaintext letters and I have assigned the numbers to each of the letters of the key. Now we go with the encryption procedure. The encryption algorithm that is given to us is we do Ci is equal to Pi plus Ki mod 26. So we have to do the modular addition of the plaintext number and the number assigned for the key. So the first plaintext number is 18 and the first key number is 22. So we'll do 18 plus 22, which is 40 mod 26. Now I have taught you how to do modular arithmetic, that is A mod B is always the answer C, where C is the remainder of A divided by B. So you have to take A, that is 40, divided by B, that is 26. 26 into 1 is 26 and the remainder is 14. So 40 mod 26 is 14. Now the next number to be encrypted is 4 and key is 8. So 4 plus 8 is 12 mod 26 and 12 mod 26 is 12 because A mod B continues to remain A if A is positive and A is less than B, which you can also see from division. That is, if I divide 12 with 26, 26 into 0 is 0 and the remainder continues to be 12. So 12 mod 26 is 12. The next letter to be encrypted is 2 and the number for the key is 18. So 2 plus 18, that is 20 mod 26, and since 20 is less than 26, this continues to remain 20. So this answer is 20. The next number which you want to encrypt is 17 and the key is 4. So we do 17 plus 4, which comes out to be 21 mod 26. So 21 mod 26, since 21 is less than 26, that is A mod B, and A is less than B, it continues to remain A. So 21 mod 26 continues to remain 1. The next number to be encrypted is 4 using the key 22. So if we do 4 plus 22, the answer is 26 mod 26. So I have to do 26 mod 26. So you divide 26 with 26. So we have to do A mod B, that is we have to divide A with B. So we divide 26 by 26. 26 into 1 is 26 and the remainder is 0. So my ciphertext number is 0. The next number which I want to encrypt is 19 and the number assigned for the key is 8. So we do 19 plus 8, which comes out to be 27 mod 26. So for 27 mod 26, we divide 27, that is A, with B, that is 26. 26 into 1 is 26 and the remainder is 1. So 27 mod 26 comes out to be 1. The next number which I want to encrypt is 12 and the key that is to be used is 18. So 12 plus 18 comes out to be 30. So 30 mod 26. So to perform 30 mod 26, that is A mod B. You have to divide A, that is 30, with 26. 26 into 1 is 26 and the remainder is 4. So 30 mod 26 is 4. The next number you want to encrypt is 4 and the number that is assigned to the key is 4. So 4 plus 4 is 8 mod 26. So 8 mod 26 is equal to 8 because when you divide 8 with 26, 26 into 0 is 0 and the remainder continues to be 8. So 8 mod 26 is 8. The next number which has to be encrypted is 18 using the key number 22. So 18 plus 22 comes out to be 40 mod 26. So how do we perform 40 mod 26? We divide 40, that is A, with B, that is 26. So 26 into 1 is 26 and the remainder in this case is 14. So 40 mod 26 is 14. So our ciphertext number is 14. The next number to be encrypted is 18 and the number assigned to the key is 8. So we'll do 18 plus 8. 18 plus 8 comes out to be 26 mod 26. So 26 mod 26, as I have already taught you, it is 0. The next number to be encrypted is 0 and the number assigned to the key is 18. So 0 plus 18 is 18 mod 26 and since 18 is less than 26, it continues to remain 18. The next number to be encrypted is 6 and the number assigned to the key is 4. So 6 plus 4 is 10 mod 26 and since 10 is less than 26, 10 mod 26 continues to remain 10. The next number which we have to encrypt is 4 and the number assigned to key is 22. So we have to do 4 plus 22, which is 26 mod 26, which is 0. So after doing the encryption, the ciphertext we have got are 14, 12, 20, 21, 0, 1, 4, 8, 14, 0, 18, 10 and 0. Now the output is basically a word. It is not numbers. We have to get the word corresponding to plaintext or secret message. Therefore these numbers have again to be mapped to the letters, which is again done using the mapping table. So we'll assign letters to these numbers now using this mapping table on the right. So number 14 is assigned to letter O, number 12 corresponds to letter M, 20 corresponds to letter U, 21 corresponds to letter V, 0 corresponds to A, 1 corresponds to B, 4 corresponds to E, 8 corresponds to I, 14 is assigned to O, 0 is assigned to A, 18 is assigned to S, 10 is assigned to K and 0 is assigned to A. Therefore, for plaintext secret message which was encrypted using the key as wise, we got the ciphertext as OMUBABEIOASKA. So as you can see, the ciphertext does not make any sense and hence keeps the plain text, which is secret message, secure from the attackers. Let us now summarize the steps to solve numerical on encryption using Vigenere Cipher. The first step is we create a 3-column table. Second step, we write down the letters of the plain text in the first column. Third is we write down the letters of the given key in the second column. The length of the key will be less than the length of the plain text and hence we have to repeat the letters of the key as long as we cover the entire plain text. Since the ciphertext is a modular addition of plain text and the key, we have to assign numbers to the plain text letters in the first column and now we have to assign numbers to the letters of the key in the second column so that we can perform modular addition of these two numbers, that is the plain text number and the number of the key. So we perform modular addition between the plain text and the key, and when doing modular addition you remember that A mod B is A if A is positive and less than B, and A mod B is C where C is the remainder obtained by A dividing A by B. And the last step is you have to assign letters to each of the ciphertext number that you get using the mapping table and then construct the final ciphertext word. So with this we come to an end of this video. I hope you understood how to do encryption using Vigenere Cipher. In the next video I will be explaining you how to perform decryption using Vigenere Cipher, where we have to use modular subtraction instead of modular addition. Thank you guys. Stay happy, stay blessed.